So this question, or these two questions that go together, the first part of it, let's look at. It says, for a biological sample in a 1 meter radius centrifuge to have a centripetal acceleration of 25 g's, its speed must be what? Well, we're coming up with some interesting things. First off, we're putting in a biological sample in a very, very large centrifuge. It gives us a radius, which is nice, but it's 1 meter. It's a huge, huge, huge centrifuge. It's over 6 feet in diameter. And it has to have a centripetal acceleration of 25 g's. So it's saying our centripetal acceleration has to be 25 times our value of g. And if g is approximately equal to 10 meters per second squared, this means that this centripetal acceleration has to be 250 meters per second squared. So the unit of a g just means take whatever your number is, multiplying it by the number of g's, and multiply that by the acceleration of gravity, or what 1g is. All right, so our centripetal acceleration for this, v squared over r. So r times ac is equal to, what the square root is equal to v, just rearranging this equation. Now I'm going to plug in some values. I have 1 meter radius. I have 250 meters per second squared for my centripetal acceleration. And that's going to give me my speed around the outside, or square root of 2500, and this is going to be meters per second if I pull the unit outside, which means my final velocity is going to be 5 times the square root of 10. Square root of 10 is just a hair over 3, so I think this works out to be about 16 meters per second. So not that hard of a problem, just realizing that the centripetal acceleration they give us is 25 g's, g being a value of 10 meters per second squared.